Hey guys, we're up and running, and this is what the view looked like about 30 minutes ago. Of course, it is dark here with fall settling in, and I've been up here 28 hours, so I may be a little bit slow, but we will get through the webcast okay. So while I get things ready, let me I'm in Meteorologist right now trying to get our satellite data ready, and that's going to take just a second. A little bit of altocumulus there in the image from earlier, but otherwise pretty clear skies here. And let's shift over to the current weather chart. And this is showing us conditions on the infrared spectrum from the Goes East satellite, and we've got a little bit of a line of showers and thunderstorms from Lake Superior down to northwest Kansas. So that's obviously going to be ahead of that front we were talking about yesterday, located out in this area here. And these storms are being fed by moisture from the south, but it doesn't look like there's much in the way of cloud layers feeding into these storms. I can see a little bit of something here that may be terrain along the Mississippi River, but very little low cloud, and this is some of that mid cloud that we were seeing on the imagery just a second ago. Now what I can do is I can run an enhancement on this and really bring out the colors. So let me do that quickly. And there we go. And we see the colder tops on these cells here, and the coldest of those tops runs about 207 Kelvin, which is going to be about minus 65 Fahrenheit or so. So if you have a SCUT, you can kind of work that out and get the storm height off of that. So let's check out the surface chart. Let me clear that off here, and you can get a look at the plots. And this is showing the very cold weather up in the Dakotas. Lots of 40s and 50s, and remember we were talking about snow up in Montana. Let's look at that little snowstorm. And temperatures in the 20s and low 30s in that area right there. Heavy snow being reported northeast of Great Falls. And even a little bit of sleet coming around the backside with the warm air coming around like this here. So even a little bit of snow showers, and I wouldn't be surprised to see a little bit of freezing rain in there. So it's a slightly unusual occurrence here. Usually these systems, they come out very dry out of Canada. So the center of the low pressure area, we can just kind of follow the streamlines to get that, and we see that that's over Saskatchewan there. And from there we can kind of pick out where the cold front is. So looks like we're looking something like this here perhaps. And then the warm front, that's going to be up to the north. That's off the top of the chart, but anyway, yeah, it's up there in Canada, well up to the north. 50s all the way from Nebraska all the way up to Manitoba. In the southern plains, we've got the tropical flow spreading north, and there it is. Flow coming pretty much right out of the Gulf, right out of the northern Gulf, though. And dew points in the 60s, which is normal for this time of year. We don't see too many 70s except along the coast. And then some of those 60s are making their way up towards those areas of thunderstorms there. And pretty good gusts there at Russell, 35 knots there and 21 knots at Topeka. So quite a bit of inflow into those storms. All right, the southeast U.S. showing a little bit of a northerly component. And remember, we were looking at the NAM yesterday. We were looking at some sort of convergence boundary, so we're going to be kind of alert to that that was kind of moving eastward with that little easterly wave. So I've kind of forgotten exactly where that is. It may be kind of stronger around that particular feature, but we'll go back to that chart a little bit later and try to pick that out. The northeast U.S., of course, under the influence of high pressure. We see the pressures themselves up to 1032 millibars and even 1034 in Caribou and Bangor. And yeah, Bangor, Maine, I was thinking about the airport there. That was out of one of the Stephen King movies. Can't remember the title, but we stopped over there in '94 going to England. We were supposed to go up to Goose Bay, and we got diverted to Bangor because Goose Bay was fogged in. That was many years ago when we went to England there in 1990. Yeah, I was in the mid-90s there. So that was my taste of the Northeast. I haven't been anywhere in the Northeast except for like Massachusetts, Connecticut, and Maine there. But yeah, I do follow the weather there. And then in the Pacific Northwest, looking like this, we can see some of the cold air coming out of the north. And even in Oregon, northerly winds. So we're going to look for a front. Let's see here. Anywhere along a line like this. And it looks like we do have some warm weather up along the northern tier here. So probably a recent frontal passage through that area. So this may be part of that front that's coming out of Montana. And then what we have here, this is probably part of an older boundary that we would find in Arizona. So we'll kind of look for a separate system in this area here. And we do see a little bit of the north wind right there, San Joaquin Valley also coming off the Great Basin area. And then southwest winds there in New Mexico and Arizona. So in between, possible front there. Okay, then switching over to the charts, let's see what we have there. Come on, charts. All right. I'm going to bring up the synoptic, the large-scale picture. This is a good chart to start with here. And there we go. We can see the dominant front well to the south. Let's see, we're on the 3rd at 6C. Let me take a look here, make sure I got that right. Okay, so that'll be for the current time right there. Okay, so even though we have 61 degrees up in Washington, that is back in what appears to be the cold air mass, so there's probably a localized cold front there, a very shallow one, and then absolutely the main cold front well to the south from the Great Plains to Arizona and then in through Southern California there. Looks like a new surge coming out of the Northwest Territories. Look at that. Very cold air. The 540 line, we trace that like that. So this is going to be much cooler. I'm not sure what the temperatures are, but I would be thinking maybe 0s and 10s coming south, 0 to 10 Fahrenheit, and then the warm front sort of like that right there. So, yeah, a little bit of excitement. One front after the other surging south, and even a fourth one here in the Atlantic, and there's kind of a locally strong area of cold air advection off the Nova Scotia coast right there. Okay, so let's see. That brings us back to the charts. I wanted to kind of go over this one more time and make sure everything is consistent. I'm going to check the time on that. Okay, that's 3 at 01Z. So we can see that, yeah, let me plot the potential temperature. And there we go. We can see the main frontal boundary very plainly through Colorado and Utah, and then it does get a little bit more vague through California, but we do have north winds there at Vegas and north at Kingman. So maybe I'll go with something like that for now. Then up to the north, we'll take a look up there, see what's going on with that next frontal boundary. Very, very shallow, but potential temperature definitely showing an impact there. The leading edge of the front, very easy to pick on potential temperature, but not showing up so well here, and that's because we're taking kind of a deeper sample of the troposphere. So we may have to use a shallow layer, like 1,000 through 850. So let's see if it shows up on that. Okay, yeah, it does show up a little bit better right there. A little bit of thickness contrast behind, but the surface temperature really bears that out. And then the other boundary running something like that right there. And then in this area here you would use station trends, kind of like I showed you yesterday. That would be the best way to find what's going on in that part of California and look for air mass changes that way, station by station. Okay, so let's see. We'll give you the current satellite loop there. And let me take a look at chat and make sure everything is going pretty good there. We got Ron Chalfont. It's been a tough day for many. Marco Mops. Welcome to the webcast here from Australia. Yeah, big difference. Austria. We'll probably take a look at Europe and see what's going on there. Funland Tech is here, and David Moore says good evening from North Texas. Kathy Campbell Wallace is here. CK Sin 01 in Southwest Oklahoma. So that sounds like Altus or Lawton or Hollis, Snyder, somewhere in that area. Tree Snyder is here. Justin Pulliam. Ryan Toomey's there, saying severe thunderstorms are impacting the Great Plains. Thomas Copeland is here, and Ryan says opening salvo for severe storm season part 2. Yeah, that's the start of the season, and maybe we could take a look at a few SCUTs ahead of these storms. So before we do that, let's get the baseline for where the storms are located. Looks like they are just west of Minneapolis and just east of Sioux Falls, north of Omaha, and then north of Russell. The tail end Charlie storm is around basically Scott City, Colby, Kansas, somewhere in there. So there it is. There's the line. So this way we can pick out the correct sounding stations. So we'll switch over and take a look at those. And we'll see what kind of air mass we're dealing with here. I'm going to use the University of Wyoming. It's a very excellent tool for looking at soundings, and we can even go back all the way to 1973, which is pretty neat. And if you want to go back even further, I've got archives on weathergraphics.com that go back to 1948, so you can do SCUTs for some of the big events like the Dallas 1958, I think, tornado, 57 or 58 tornado. Okay, so let's check out the weather ahead of that front. We're going to set it to the evening conditions, and we're going to look at Omaha. That's going to be a pretty good sounding. So here it comes, and this is the dump of all the data, so we're going to change that. Okay, so there's Omaha coming up. So 0Z, we got to keep in mind that this is an evening sounding, so there's not really a need to factor in surface heating because we've already have it there. Looks fairly a little bit dry in the low levels there. If we extend this average moisture down to the surface, we get a dew point of about 61 to 63 Fahrenheit. So yeah, that is definitely on the dry side. Temperature, that works out to about 27 Fahrenheit. That's going to be about 81 Fahrenheit. I'm sorry, 27 Celsius, 81 Fahrenheit. You can see there's probably a little bit of a radiational inversion setting in there as the sun starts to go down. However, we can see that the mixed layer moisture gives us a dew point in the low 60s and upper 50s. So we're definitely dealing with elevated storms, it appears. There's that inflow there coming out of the south. 30 to 40 knots there. So we've definitely, at least I think we've definitely got elevated storms there. Base is up at about maybe 7,000 feet there. And so we get the parcel intersecting right about there. And there's the parcel lifting through the column, and there's probably been a little bit of change with that environmental trace to kind of allow the parcel to move upwards without any without any negative energy there. So there's the equilibrium level up. That's going to be up at about 43,000 feet or so. And then the anvil tops are going to be up a little bit higher there, the overshooting tops. That's going to be up at about maybe 45,000 feet or so. Okay, we'll take a look at another sounding. We'll head up to Topeka, a little bit further ahead of the line. Moisture profile looks very similar there. Dew points in the low 60s there, so elevated storms once again. So our LCL is way up high, and that's going to really cut down on the tornado potential. When your LCLs are high, that's a major indicator that your tornado potential is going to be on the low side there. You really need some pretty good relative humidity in that inflow layer there. So parcel goes up like that, and we've got more convective inhibition there, a little bit more capping. And what looks like is happening, looks like Topeka is right there, Omaha is right there, and it looks like the air mass here is a little bit more capped. Here it's a little bit less capped, and that's probably due to the approach of some upper level dynamics coming from the west or from the northwest there. So a little bit of lift of the column. Not quite working on Topeka just yet. And then we'll try one other sounding here. We'll try, I guess we can try Minneapolis a little bit further up the line. And there's the evening sounding. We've got kind of a humid trace all the way up to about 10,000 feet. And I suspect the sounding probably went up into a cloud. You can see it starts out very, very humid right off the ground right there. And humid all the way up. So I think we've probably got a little bit of convective contamination. I would probably go to the METAR reports and see what's going on in that area. And maybe look at the balloon launch with respect to the radar. So this is a little bit suspect right there. Dodge City further down to the west, that's going to be south of the tail end storm. And moisture looks exactly the same, dew points right around the low 60s there. But apparently there's a little bit more capping in that area. Maybe this is kind of critical this layer of capping that we've got at about 9,000 feet or so. And then above that, definitely some positive area. So that's going to certainly support thunderstorm activity. But as you can see, they didn't get it down there in Dodge City, which is located right there. So a little bit of capping holding on in that area this evening. And they've got a couple of other neat little tools here. The STUV diagram, we can give that a try. Plot that for Dodge City, and you can see that there's a difference here. Instead of skewing the skew T lines like that, we stand them straight up. So we've basically got an XY graph of temperature versus altitude. And when we plot our data, it leans way over to the left. And it's very difficult to do our calculations on this, because every diagram is going to lean way over. And that's why we use the skew T. It's much easier to analyze compared to this diagram right here. We do have the convective indices on here. We've got, I guess I can go through some of these. We've got the station latitude, station longitude, the elevation in meters, the Showalter index. That was one of the very first convective indices from the 50s. We've got the Lifton index. And when we're in the negative range, that's a good sign that we've got conditions that are good for thunderstorms there. We've got the Lifton index with the virtual temperature right there, the sweat index, which is interestingly very high, 422. That would be forecasting tornadoes there. But obviously they're not taking into account all of the factors going on. Doesn't look like a tornado sounding to me. I guess, we do have a pretty good wind profile there. A little bit of turning there, and that's what the sweat index does pick up on with the shear term. And definite good instability there. Let me give you the other diagram there. Yeah, so definite instability, but the problem is it doesn't really account for the dry conditions, the high LCLs. So that's some of the problems we have with those older indexes. K-index, cross totals, vertical totals, those are kind of like indices of the lapse rate, shows kind of how far over to the left the line leans, especially this vertical totals. And cross totals, that kind of gives us a mix of like moisture and the temperatures aloft. Total totals, and then a CAPE, that's the important one. You should definitely check that out. But keep in mind that in the morning, that may not be representative. Sometimes you just don't know where they get that CAPE. Sometimes they're just lifting the surface temperature. Other times they're forecasting the maximum temperature and then lifting that there. CAPE with virtual temperature is right there. Convective inhibition, and then convective inhibition with virtual temperature right there. So that's a measure of capping, 66 joules per kilogram there. I guess that's what we have in this area right there. Yeah, this area right there, that's the convective inhibition. Okay, then we have EQLV. I would have to check my notes. I can't remember what that is. Level of free convection right there, that's kind of where the parcel goes to positive energy. So there's the level right there. We can read that off, and we get a value of 700. So that's pretty close right there. And then there's the LFC with the virtual temperature. Then we have the Bulk-Richardson. I think that's the Bulk-Richardson number. I'd have to check on that. The LCL. 287. Lifted condensation level, 784. Yeah, that's 784 right there. That's the LCL. And I'm not too sure what this T1 is. I would have to check the documentation for that. Then we've got the mixed layer. Okay, I'm trying to remember what these other ones are here. This could be the mixed layer mixing ratio right here. Sometimes we just don't know what the abbreviations are, and we have to kind of go to where these diagrams are documented. But that's what that looks like, 13.20, and certainly when I look at that line right here, that falls right around the 13 grams per kilogram area. So that kind of gives you what line they're considering, I think, right there. Then we have the 1,000 through 500 millibar thickness, and then precipitable water. That looks awfully high, 32 inches. Okay. Yeah, let me compare that with another station there. We're going to go to Springfield. Precipitable water, 29.13. I wonder if that's in millimeters there. Okay, yeah, pretty good loaded gun sounding there at Springfield. However, lots of convective inhibition, and we can see that right there, 474 joules per kilogram, keeping things very shut down. And the dew point looks to be pretty dry. 59 degree dew point there with 80 degree temperature. And yeah, mixed layer mixing ratio 11. So that's going to put it pretty low there. We really want to see that coming up to about 13, 14, 15, 16 there to get into the upper 60s and lower 70s dew points. And maybe I could bring up the big storm from 2013. May 31st, 2013. That was the El Reno storm. And that was the one that caught Tim Samaras and his son and Chris Young there, and was associated with quite a bit of instability there. So this was the morning sounding there at Norman. And what we see on this is the moisture definitely a lot higher. If we bring that down to the surface, we get a temperature of about 21, 22 Celsius, which is going to be about 70 Fahrenheit. Mixed layer mixing ratio 17, so that's come up quite a bit. So we're kind of factoring things along that 17 line. And then we take into account the high temperature for the day, and I think we were looking at maybe 93 degrees. So that would be about 33. And then we bring that up against the 17 line right there. And obviously there were some changes during the day, because right now there's a lot of convective inhibition there. You can see minus 243, so something did change the environment during the day, and that's the reason that the 18Z soundings are so important. So we can monitor those changes, and the models, to a certain extent, they can keep track of those kinds of changes. And man, look at that cape, it's just phenomenal. Let's see, where's the cape? 2856, and I think that's going a little bit conservative. The most unstable cape, that's probably going to be a little bit higher there. Very steep lapse rates all the way up. Vertical totals about as high as it will ever get, 29 to 30. And then you can see that with the moisture being very high, If we get things kind of cooling down in the storm environment with parcels about 84, 83 degrees Fahrenheit, we get kind of a low LCL like that. And that's going to be a height of about 4,000 feet. So high relative humidity through that layer and low LCL, and that's what's going to bring up the potential for tornadoes there. And a very strong shear there in the lower levels. 50 knots there just off the surface, and if we can turn these winds around, kind of keep them strong, and turn them around to the south and to the southeast, that's what will really help the helicity in a situation like this. The turning is good, but if you don't have that strong speed in the low levels right there, you're just going to get kind of a unidirectional profile. Let me see if they have any photograph tools. Yeah, I think they do. Yep, so there's our photograph there on May 31st. And you can see they've got the levels here in millibars outlined. So 850 is 5,000 feet. That's located right there. And this is showing us that the winds at 5,000 feet relative to the ground are out of the west-southwest at about 25... What units are these? I think those are probably meters per second. Yeah, we did have a 50 on there. This is going to be meters per second. So anyway, yeah, there is a little bit of curvature on the diagram, but if we can really get those strong south and southeast winds, that's what will really stretch this line over onto the other side of the diagram right there. I can already see that our storm motion is going to be something like this. So we would end up sweeping out a pretty large area. In this geometric area in the lowest 1 kilometer, that's going to be the helicity. And in this case, it was quite large. And then we can try to compare that to today. Let's take a look at that. October 3rd. And we'll go to Topeka. And there is a little bit of curvature in the photograph. But we got to keep in mind the lowest 1 kilometer. That's going to run from, in this case, about 976 up to about 910, 900. So that's the lowest 1 kilometer. The storm motion vector, that looks like it's going to run something like that. So yeah, we do sweep out a little bit of area here. The scale is a little bit lower here, so we're not quite as stretched out. So this is kind of a smaller storm relative helicity, but the big problem with the storms here is the high LCLs, the low moisture there. But overall, pretty good winds. This is meters per second, so we're definitely getting a good low-level jet here in the low levels, about 2 kilometers off the surface. A strong south wind there at about maybe 30, 40 knots. Okay, so that's a little bit of storm forecasting, and we'll just kind of head into the forecast here. And we'll go region by region. And I'm having some trouble with these College DuPage models. They have not updated. See, it's still got yesterday's from the first at 18Z, even though the URL shows the second at 18Z, so I'm not too sure what's going on there. But anyway, we can see the little snowstorm there in Montana. Let's see, that's going to be about the current time right there. And then we'll just see things cooling down in the wake of that system. And lots of freezing temperatures across the Great Basin area. For the southwestern U.S., this evening it looks like this. There's the north winds right there, and we know that there is some sort of front in this area right here. You can definitely see it there in the Four Corners area. And then over the next day or so, we'll see that front sag south through the northern Arizona area. Freezing temperatures in the high deserts of Nevada. And then things warm up tomorrow. And a very strong southwest wind there. So we're just going to have kind of a quasi-stationary front there through the desert southwest. Let's see the Central Plains here. Current chart is going to be looking about like that right there. And looks like we've got kind of a quasi-stationary front there also. Then finally, looks like tomorrow afternoon it makes some progress to the east and stalls out yet again. Just not making very much movement there, but a lot of cold air locked up there in Montana and Wyoming. The Southern Plains, not very much going on there, just kind of the southeast flow there across Texas. And you can see we're dominated by high pressure way out in the southeast U.S. This is kind of part of the Bermuda High extending out to the west. In that front that's got all the cool air, we're just kind of waiting on that to get down here. It's kind of teasing us up there in southwestern Kansas. Okay, southeast U.S., let's see, the third. Okay, I guess we had that little easterly wave. I guess that might be around New Orleans. Florida is now kind of under a northeasterly flow like this. I would imagine that would cut down the precip a little bit. I can definitely see high pressure building in there. So under the influence of that big high there in the northeast U.S., but not much relief as far as temperatures, and it looks like a few spots of convection there around Fort Lauderdale. And then for the northeast U.S., and they've been hogging a lot of the cold air all summer. We're starting out like this evening, 50s for highs. Then in the morning, we're just down to the 40s and 50s. High pressure covering the entire area. And then the high pressure just gradually moves out to sea there. Okay, so we'll take a look at the big picture here and wrap it up. Maybe we'll start with the European model once again. Let's see, we got Bill Johnson up in Milwaukee there. Ryan says the hail has been pretty impressive from some of the live feeds there in the Great Plains. Baseball and golf ball-sized hailstones falling. Hail, fog, landscapes with sporadic damage. More rain falling in Puerto Rico, adding insult to injury during the recovery process. Troops and federal employees working hard rebuilding the infrastructure and clearing roads. And Marco Mops reminds us that EQLV on those soundings is, yeah, the equilibrium level. So EQLV, that would be the equilibrium level with the virtual temperature there. Ryan says 30% power is restored on the island. The airport is about 50% in operation, which is good. Great to see U.S. teamwork coming together and moving forward among folks instead of political infighting. Yeah, especially in a place like that that's so vulnerable. That's good that we're kind of digging out of this mess there. Kevin McKinney, and enjoyed going through the soundings. Okay, so let's head into the forecast. The main front well to the south, like that, and there's our other little system up in the north. Then over the next week or so, you can see these high pressure areas that kind of make a major impact on the charts. This one moves to the northeast, or it moves to the southeast there on the 4th on Wednesday. And then it modifies. Yeah, it looks like it moved pretty quickly out towards Illinois there. Cyclogenesis in the Great Plains right there. New high coming together in Idaho on Friday. Then we see some pretty major cyclogenesis up there in northern Canada. And we'll see what that brings. Brings a large Pacific air mass into the western and central U.S. And this one looks like it punches southeast pretty strongly. So this is the cold front on next Wednesday. The day before that on Sunday looks like the leading edge is something like this. So finally we got a front that has the energy to make it south. So there it is. That'll give us a change on the 9th. And that covers the central U.S. And then it just should stay mild through that period. So yeah, looks like we've got tropical air here in Texas until, yeah, look at that. There's kind of a change in the gradient here in Texas. This is the Tuesday morning map. Southeast winds in Texas. And then for Wednesday, we've got more of a easterly gradient. And the wind does flow at a little bit of an angle to these isobars, so maybe a slight northerly gradient there. That'll kind of dry us out, give us some cool nights, maybe Wednesday night. And a little bit of a disturbance going on in the Gulf way off to the south. Yeah, there's that. There it is appearing Sunday. Something coming up out of the Gulf. And then crossing over Florida. 997 millibars. That should just be a little tropical depression there. And in the wake of that, we get the cold air coming in. And looks like that makes it all the way up into parts of northern Florida there. Okay, then we switch over to the GFS. You can see the thickness lines are just kind of piled down to the into the central U.S., into the southwest U.S. like that right there. So it's kind of a stationary front for much of the week there. There comes that disturbance there over Florida, the GFS going a little bit further to the west, it looks like. Looks like kind of a track like that, bringing it onshore in the New Orleans area. Let me check that out one more time. Yeah, making landfall around New Orleans on Saturday, so GFS going like that, and the European model taking it more like that. Then going into Sunday and Monday, we start looking to the west, and we're looking at that high pressure area. We're expecting that to start building in. And the GFS going not quite as aggressive with that high, and in fact it's moving it more towards the northeast U.S. It's like a big magnet for cold air masses, and it's kind of aggravating to see that. And then the GFS finally kicks something southward on Thursday. So we'll see how that works out. Then things clear out a little bit, and then we get another shot of cold air coming southward, and these should get progressively more and more strong because of the production of cold air up in the northern part of Canada there. 5-10 decameter thickness coming down south. Yeah, that's some seriously cold air. So we should see it get progressively colder during the second and third week of October here. And with that, a chance of some thunderstorms. Okay, so that's about all I got for tonight. That's our 48-hour run, so I appreciate you all joining us, and hopefully we'll see y'all tomorrow. I am thinking about maybe switching off to 8 o'clock. I haven't decided about that, but you may want to kind of watch the titles on the webcast. Otherwise, we'll see y'all tomorrow at 9. Take care.